Arunava, I shared the screen.
Okay, nice, nice, nice. Fine. Um,
Yeah, it's working.
okay. So I guess we should start. Um or do you guys want to like share? Like nobody's talking except me and Prabhu.
Actually, there were many people, Arunava, due to some technical issues, it was bit off. I mean, there was bit delay. I think you knew. We are so sorry for that. So very many people, I think, like they didn't get in. Let's start it by. There's no worry. You can start. You can start with the
Okay.
agenda.
So what I'm going to do, like what I'm going to talk about today is like how to get started with deep learning and the basics of Pytorch, right, Prabhu?
Yeah, exactly, exactly, Arunava.
Okay. Okay. So, so like, uh, so since we're starting with deep learning, let me first start with, in general, what is deep learning? So the idea of neural networks is there for like from the 1990s, but they were not like the best solution at that time, because of many reasons. We didn't have proper algorithms to train these neural networks. We didn't have the proper amount of data sets that these neural networks need. We didn't had proper computer infrastructure that these algorithms need to train upon. So due to a lot of issues, neural networks back then, like the research stopped. I mean, many researchers stopped researching about these because it didn't seem like the right direction to go. But they are in fact the right direction to go. But like many researchers continued, like Hinton and Ian LeCun and Bengio, they continued researching on neural networks. And by the time they came up with super fast, I mean not super fast. By the time they came up with algorithms that really worked out, they actually. It was a time at around 2008 and something. So by that time, even Google came into picture, and all these big tech giants started coming into pictures, and they also had started collecting many data, like a large amount of data. So using all these data and everything, they actually uh, were able to train algorithms, these neural networks, which were able to perform better in any task, right? Yeah. So that's how deep learning started. We call it deep learning because we stack layers of neural networks, one behind the other. So the idea is that the deeper the network is, the more features it extracts. But currently, it doesn't exactly happen like that because there are a lot of uh, like the training algorithms are yet not perfect. We need to research a lot on that. So after that, we might be able to like train algorithms that are perfect, right? Okay. So with that, I guess Prabhu can move to the next slide. That gives a basic introduction.
Hmm.
Yeah. So the main focus will be on how to get started with PyTorch, how to get what are the basics of deep learning, and about secure AI. Since you guys are in are working in a company on a product, I believe that secure AI should be one of the main focuses of one of the main focuses for like one of the main considerations for you guys, because as you're working in a company and most probably you have a product which collects some data from of the users, performing secure and private AI, like techniques like federated learning and differential privacies. These things come into the picture when we talk about data that you're collecting from users, and you need to keep those data. I mean, at least those users private, like whose data it is exactly, right? So that is the thing I'm going to slightly touch upon and give some like pointers to where you should go next to learn more about these, right? So move to the next slide, please.
Yeah, sure.
Okay. So what is PyTorch? PyTorch is a deep learning framework that allows you to train deep learning models, very easily. So if everybody is familiar over here with TensorFlow and with TensorFlow is also like a deep learning framework which allows you to train deep learning models and easily deploy deep learning models and perform all sorts of things. Yeah, right. So Pytorch is something similar to that. This is from the Facebook research team. The creator of Pytorch is Sumit Chintala, right? And Pytorch is like it's written over here. It's a Python-based package for serving as a replacement of NumPy. It's not exactly a replacement of NumPy, so maybe you can change that, Prabhu. Not right now, but it's not exactly a replacement of NumPy. It's like it's a differential library which performs, you can say, uh, which contains autograd. Autograd is something like it performs automatic differentiations for you. So whatever operations you do, it performs the exact differentiations for those operations, right? So it does that automatically for you so that you don't have to take care of those things, because when you're training neural networks, you have to perform differentiation to calculate gradients, and PyTorch does that easily for you. And PyTorch, one of the main reasons PyTorch is very famous is because PyTorch is Pythonic. TensorFlow is not Pythonic. TensorFlow, I don't want to say this out loud, but how many of you are, over here use TensorFlow?
I guess like
Huh? Sorry?
only few people worked on TensorFlow.
Okay, your voice is very low.
Um, I think TensorFlow. Many people. Many people are not aware of TensorFlow. I think, Arunava.
Okay, fine. Okay, so the point is like um, Google made the TensorFlow API so complicated and so disrupted that people, like many developers and many AI developers, actually believe that TensorFlow is going to die in the future. Like maybe it's not true entirely. I mean, it should be, because I personally have observed and even talked with Google engineers who actually don't know what's going inside the library. I don't want to propagate a bad message message here, but yeah, kind of that. Okay, so in my opinion, PyTorch is much better, and PyTorch is uh, um, yeah, okay. So what PyTorch does is it brings this Pythonic touch, and you can do deep learning using the same kind of things as you do in normal Python operations, right? So that's the advantage of using PyTorch. Okay, move to the next slide.
Yeah.
Okay, so when we're doing deep learning, we use the most famous data structure, which is called tensors. So tensors are basically like everyone over here is familiar with matrices. So you have matrices, and then you have you have matrices, and when you stack two matrices on top of each other, you have a 3D matrix, and then that you can think of that you can think of increasing the number of dimensions, and then you have 4D, 5D, and those are not called matrices exactly, but those are like those are then called tensors. So in general, when you're saying tensors in terms of PyTorch or TensorFlow, what you generally have in mind um, is like even a number, like one scalar value like a 5 can be represented as a tensor. So it's kind of a data structure which stores the values, the weights, images, and every other kind of data. So tensors are data structures that stores the data, be it the weights of the model, the input to the model, the output of the model. Tensors are the way to go. Okay, next slide please.
Yeah, sure. Okay. Is it like operations?
Okay, so yeah, so we have like this slide is like operations in PyTorch is like very simple. So you don't have to like do something crazy to perform operations on tensors. You can just do a plus b, where a and b are two tensors, and you can just add them up, right? So operations is pretty much the same as Python. So if you're familiar with Python, you shouldn't have any problem with operating on tensors in PyTorch. So the first place that I'll suggest you to look at is the pytorch.org /tutorials, where you will get plenty of hands-on stuff where you can try out and start getting
Excuse me.
getting a feel of how to use PyTorch and how to get into PyTorch. So PyTorch also has a discourse forum
Hello.
where you can put your questions. Sorry, you have a question?
Yeah, I have a question.
Okay.
So, PyTorch is it a library in Python or is it a language?
It's a library.
Oh, you have to import like
Yes, import
uh,
PyTorch.
okay, like TensorFlow, right?
Exactly.
So what's the difference between it'll automate differentiations? That's what you say, right?
Yes, it will
That's
automate
only
differentiations. And have you used TensorFlow?
yeah, a little to build deep learning
So
models.
if you have used TensorFlow, then I will suggest you to go to the pytorch.org /tutorials. And if you can see through its examples, you can see that it's pretty Pythonic. I mean, you don't have to start sessions. You don't have to the main difference between PyTorch and TensorFlow is PyTorch is builds dynamic graphs. So in TensorFlow, what you have to do is you have static graphs. You have to build your graph first, and then you have to execute operations on it, right? Am I right or wrong?
Yeah.
Exactly. So in PyTorch, you don't have to build graphs first and then execute. The graphs are built in a dynamic fashion. So as you go forward, the graphs are built. Okay. So there's a lot of
Okay.
things in TensorFlow, like you have to start sessions, and you cannot see what the output of the operation is without running a session and things like that. They have actually brought in eager executions and things, but yeah, that's what happened in TensorFlow 1.x. They have changed things with 2.0. Obviously, they're getting a competition with PyTorch, but TensorFlow in general has a lot of other things like TensorFlow serving and TF Lite and TF Mobile and everything like that, right? Okay, so was it clear?
Yeah.
Okay, so just like if you have questions, please.
Yeah, Anup,
Yes.
functions of Tensor.
Sorry.
Would you please elaborate the functions of the Tensor? See, I'm new to this, but just I'm hearing the words like Tensor. Can you please elaborate the functions of?
I'm sorry, I'm not able to get you.
No, like he's saying like he's new to tensors, so he's saying can you elaborate a bit about like what are tensors exactly?
What are tensors?
Yeah.
Okay. So let's say you have one number. Okay. So can you please come to the mic or something like as you're talking?
Yes, I'm in a mic now.
Yeah. So let's say you have a number, right? In Python, if you have a number, it's an integer, right?
Right.
Okay. So you have this integer, and if you call torch.tensor of that integer, it becomes a tensor. So it's just a data structure. So if you print that out, it will just print torch.tensor of 5. So that's a tensor
Okay.
now. So
Mhm.
even if it's a scalar value, like even if it's one value, it can be represented as a tensor. And then if you have like a array of values, which are called vectors, right? You can represent that also in tensor. So let's say you have a numpy.nd array, which contains 1 to 10 numbers, and you can also represent that as a tensor. So everything is a tensor. Like it's a data structure which contains n-dimensional arrays. You can store a number, you can store a vector, you can store a matrix, you can store any type of thing, right?
Got it. Thanks.
Okay. Okay. Next slide.
Yeah. Sure. Yeah.
Okay. So, okay, just excuse me for a minute. Hello. Okay, sorry for that. Just a minute. Okay, so yeah, so in general, in deep learning, you have feed-forward networks. So these are the most common type of networks: feed-forward networks, convolutional neural networks, and recurrent neural networks. Okay, so feed-forward networks are maybe like Prabhu, you have access to internet.
Yeah, yes sir, no?
Can you just go to my Medium page? Like, can I share my screen? Because I would
Yeah,
have.
you can. I'll stop sharing, you can share your screen, okay?
Okay, just switch off your share. Okay.
Yeah, I'll stop. Yeah. You can start sharing your screen.
Let's see. Let's see.
Yeah.
Okay. It's visible, right?
Yeah, it's visible.
So the thing is, you won't understand without a clear picture. So let's say you have this. This is visible, right? Fully connected layer.
Yes. It's visible or no?
Okay. So let's say you have this. Oops, sorry. Let's say you have this. This is a feed-forward network. So let's say you have a row of data. Let's say you have an image, a handwritten image of 2. So if it's a 28 cross 28 image of 2, then you can actually flatten this entire matrix, and then you have a vector of 784, right?
Yeah. Yes or no?
Okay, so you have this long vector, and just for the purpose of thinking, let's just say I have a vector of 5, right? So an array of numbers which contains 5 numbers. So a vector which contains 5 numbers, and then this number is actually connected to another layer. So we call these middle layers as the hidden layers, and the last layer as the output layer, and the first one as the input layer. So what is in basic happening in these layers is a matrix multiplication. So the input vector is multiplied with a matrix which contains the weights of the neural network. Okay, so this matrix, which is of dimension um, so n comma m. Okay, so what is n? N is the number of neurons, or the number of the length of the vector which is in the previous layer, and m is the number of outputs you want to have. So if you compare this the just what I said with this picture, then you will see that this has 1, 2, 3, 4, 5, 6, 7, 8. So 8 neurons, and 8 values are coming in, and I am outputting 1, 2, 3, 4, 5, 6, and 6 values are getting outputted. So my matrix is of size 8, 6. Okay, so this input vector 8 is multiplied with this 8 cross 6, and out comes this 6-dimensional vector, right? Was it clear?
Yeah, we got it.
Okay, so you have this inputs, and then you have these outputs. Okay, fine. So you have these inputs, and then you have these outputs, and in middle what you have is matrices which contains these weights. So since we have access to my screen, I'll just quickly show you some results. So let's say this is how you import Pytorch, import torch, right? Is it visible? Okay.
No, it is not that much clear now.
Should I do like this? Prabhu, can you let me know, like, is the screen visible or not?
Yes,
Like
sir,
what
no.
I'm typing?
Yeah, it is visible now.
Okay, it's visible, right?
Yeah, it's visible.
Okay, so let's say you define a tensor, and this is how you define a random tensor. Okay, so let's decrease the size. Let's say you have this tensor of 5,5. Okay, so if you print it out, this is the tensor you have, right? 0.7571 minus 1.0673, and every like random numbers put together in a 5x5 matrix. And this is a tensor. Okay, this is a tensor. So a tensor is an n-dimensional array, as I said. So you have n1 as a tensor, and where was I going? Okay, linear layers. So, and you define a linear layer like this. So import torch. Now, people who are familiar with TensorFlow, you can see a noticeable difference here. So let's say the input that is coming to this linear layer. So linear is this layer, which I just showed over here. So the linear layer, let's say I have like three values will be coming in and 4 values will be going out. Okay, this is my linear layer. And if you do a L1.weight, you can see all this is the matrix. As I said, like, if you can see, it's a 3x4 matrix because 3 values are coming in and 4 values are going out. Okay, and let's say I have this tensor now, which is of size 3.
Sorry, Arnav, we cannot see your terminal. We can see the towards data science block.
Can you see it now?
No, Arnav, we only see the blog.
Okay, in that case, I don't think like I can share code samples, right? So
Yeah.
I just
no, you can just explain like this.
Okay, fine. So okay, so you have these you have these fully connected layers, and these layers are actually fully connected to one another, right? And so you have this you have these 8 neurons coming in and this 6 neurons going out, and you have this matrix which stores the weight. And this happens one after the other, like matrix multiplications on top of each other. And finally, you reduce all these to just 2 outputs. And these outputs are actually store the like the result. So let's say you are training a neural network which learns to classify between dogs and cats. Like you can, if you give it an image of dog, it will say it's a dog, and if you give it an image of cat, it will say it's a cat. So so you have 2 outputs. One the value of one goes high if the image is a dog, and the value of the other goes high if the image is a cat, like that, right? So if you're training this neural network, then you'll have this input layer, you'll have some hidden layers, and then you'll have 2 outputs. This is a normal classification problem. Okay, so this is how fully connected layer works. But let's say you have this image of a dog, and to pass this to a fully connected layer, you will actually have to flatten it out, right? Because it takes in a fully connected layer takes in vectors as input, right? So you have to actually flatten the entire thing out. So by flattening an image, what happens is you lose spatial correlations. So let's say I'll give you an image of a dog. Okay. So you take an image of a dog, and you can tell me like, okay, this is an image of a dog. Just with one look, you can tell, okay, this is a dog. But if I give you the same image in a flattened manner, like flattened in the sense all of the pixels are in a straight line. Okay. So all the pixels taken into a straight line, and all this, and then if I give you that image, will you be able to tell me with the same accuracy that is a dog? You won't be able to tell me, right? Well, neural networks can up to a certain extent, but then they're also, I mean, we lose the spatial correlations like the ears and the noses and nose and the eyes. We lose that thing. We lose that entire information because we're flattening the entire thing out. So we keep the image as an image and we introduce a new layer which are called convolution layers. So what convolution layers does is it takes in an input and then you have what are called kernels. So you have this let's say, okay, fine. So let's keep the dog example on one side and let's just understand what convolution layers are, then let's go back to that. So on the screen you can see like the example of the image of a general convolutional neural network. So you in convolutional neural layers, in convolutional neural network, or in general in convolutional layer, this is a convolution layer. So you will have an input which is of height h1 and w1 and of width d1, right? So you have this thing, and in case of a normal image, a normal image has RGB channels, right? 3 channels. So my D1 will be 3. So D1 indicates the number of channels, and H1 and W1 are the height and width of that image. So you have this image, and we represent this image as a tensor, right? So you have this image, which I'll call as a tensor from now. So you have this tensor, and we perform the convolution operation on this. What is a convolution operation? Is that we have a bunch of filters. Filters, we also call these kernels, right? So we have these kernels, and if you can see, like I have D2 kernels, and each kernel is of the size H2 cross W2 cross D1, right? So H2 cross W2 cross D1, and if you notice, each kernel has D1 channels, and my input also have D1 channels. So one kernel can entirely sit on the input image, and then I can perform my operation. So let's take things down, and let's think that D1 is 1, right? In that case, I have a 2D matrix which has H1 and W1, like height and width of a certain height and width, right? And I have this one 2D matrix, and I have this one convolutional layer. Okay, so I have this one convolution layer, and what this convolution layer does is it sits upon this image. It's a webinar. Okay, so it sits upon the image, and if you take a small example, so let's say I have a 4x4 matrix, and I have this kernel which is of size 1, so it will sit on that on the convolution on the image, and what we do is we perform a multiplication, and then we add things up. Okay, so let's say we have this kernel of size 1, and it sits on top of one pixel, and we perform a multiplication, right? And we get the output. So this is the output that goes to the complete like the output of the convolution layer, which is this green layer, right? So the same thing happens when we have multiple channels. So in case of multiple channels, all the values gets multiplied, and then they get added up, and then it's placed in one, like in this pixel. Like, it's very difficult because I don't have a board. In like one pixel over in this output layer. Okay, the same thing happens with all the D2 channels, and for each D2 channel, we have one channel in the output. So this gives the final output of the convolution layer. If it's confusing, just go through the blog once, you will understand it. Fine. So you have this thing, and what the model learns here is these filters. So these H2 cross W2 cross D2 things, this kernel, the model actually learns this. Okay, so what the model tries to detect is like edges and like various types of features that are representative in the image, right? So the model learns this, and then it gives an output, and these outputs are passed through more convolution layers, And in general, when you're talking about convolutional neural networks, you have kind of three types of layers, which are convolution, pooling, and fully connected. And after a convolution layer, you have a pooling layer. So what a pooling layer does is, yeah, kind of very intuitive. So you have this. Let's say you have, this is a kernel, the green, complete green thing is a kernel, and you place the kernel on top of that image. So the kernel is placed on 78, 67, 56, and 12. And when you're doing a max pooling, it takes the maximum element from that. So the idea is that it takes the most representative feature in that part of the image. And we do that, like the kernel moves. So one thing I missed is that kernel moves from one place to another, right? So let's say the kernel is sitting over here, and then the kernel will move by a stride of 1 to this place, and then the kernel will move again. So when the kernel is completely over here in this blue region, then it will give the output of 94, right? Yeah, that's one thing. And another one is like in case of average pooling, like if you're doing an average pooling, then instead of taking the max, it will take the average of all the numbers, right? Okay, so you have these convolution layers and pooling layers, and finally you have this final output, which you actually flatten. And you can actually see an example of flattening over here. So let's say you have this final output 78, 94, 62, 83. When you flatten this, it becomes 78, 94, 62, and 83. So in a vector format. And then you pass these through a fully connected layer, which I just talked about, right? So after you again pass these through this, then you will get the final outputs like it's a dog or a cat. So what happens is, bringing the dog and cat example back. So this time the kernels are able to learn like representative features of that makes the image cat or a dog. So it can learn about years, and it can learn about how the years are in case of a dog, and in like the difference in case of a dog and a cat, how the eyes are, the nose, and everything, like the representative features of dog and cat. It learns that, right? So you don't have to like do some traditional image processing techniques to bring that into the picture. Yeah, so that was about convolution layers and feed-forward networks. And it's already 12:04, so I'll try to wrap it up quick. Where is the thing?
Exactly, or no? Like we can have a talk on secure AI a bit. I mean, for 5 minutes, and we can wrap up.
Yeah. Where is the slide? Oh, Prabhu, share the screen.
Yeah, I'm sharing.
So you have these convolution layers, and then after that you have recurrent neural networks. So in a very brief manner, recurrent neural networks are basically allows like to propagate one information one after the other, like in a time step manner. So I'll be quickly skipping because participants are coming in. So can you just move to the secure AI part too? Yeah. So okay, let's not go through every technique out of time. In case of security, what we are mainly focused on is the data that is coming in case of like, let's say you're a company, right? So you have products. Your products are collecting data, right? And when you're collecting data, you need to take that responsibility that the data isn't leaked in a fashion that the data, like the person who has this data, like that person isn't leaked. The data can be leaked. The data, we need the data, right? But who's that like, sorry, I'm getting all messed up. Like who's the data belongs to, right? Like the data belongs to a person. I cannot leak whom that data belongs to. Like, what's the word? I'm missing the word, right? So I cannot leak the person whose that data is, but I can leak the data itself. So I have to take care of things like I have to encrypt the data in a manner that such that it's not leaked. And on the screen, you can see an example of federated learning. The slide of federated learning. So what federated learning is that basically, instead of instead of taking the data up to the cloud, like let's say you have your Google Photos, right? Your Google Photos, in Google Photos, what happens is you have different images and stuff, and all of these are uploaded to the cloud where things are getting classified. I mean, they're not getting uploaded to the cloud. Maybe federated learning is happening, but the point is like without uploading everything to the cloud, the model comes, like the model is sent to the device, and the model is trained on personal information. So the data stays inside your mobile and your data isn't leaked. So the user feels safe that their data isn't leaked, and you have a model which is trained on personal data, which can give you personal suggestions. So it's not a model which is trained on data that is coming from like everyone out there, like the complete world out there, but it's data that is coming from you. So you have a model, you have an assistant that's personalized with your data, so it can give you suggestions with your data, right? And the main thing about secure AI and private AI is that you don't want to leak information out to anyone, right? Of anyone. Okay, so I have this data. Let's say I own a dog, and I have this picture, and I take this picture with my dog in my bed. So let's not go into like pictures. Let's say I have this cancer information, or okay. Okay, I'm getting confused. Okay, Acha, fine. Okay, I'll quickly wrap it up. Yeah, so the main goal is like you cannot leak the data of the person you are taking it from, right? So I'll give you a short example. So let's say I'll give you the example of antitrust. So let's say you have this study going on where you're taking in suggestions, I mean answers from a group of bunch of people who has done a certain crime, and you want to take that information in a manner, in a certain encrypted manner that even the data holder doesn't know that whether that information is true or not, but still you can perform your statistical analysis in a manner that you can still get your desired results, right? So you don't know that data is encrypted in a fashion that even the data holder doesn't know whether it's true or false, but you can still do your statistical analysis in a fashion that you can get your like required results. So that's the goal. That's the goal, right? Okay, Prabhu, move to the next slide.
Yeah, no. Can you see now?
Okay, let's skip this one. It will take time.
Yeah.
Okay, so yeah, okay, fine. I'll just give you some pointers where you can go and learn about this. So the first place to go is pytorch.org/tutorials, right? You go over there and you can learn about PyTorch. And in general, if you're trying to learn about deep learning, you can go to the deep learning specialization course in Coursera. That's the best place. And to learn about secure AI, secure and private AI, and how to use PyTorch along with PySift. PySift is a library with which you can perform federated learning. So how to use that along this, you can do that. You can actually take the Audacity course, which is free. I'm currently doing that course. So it teaches you what's the importance of differential privacy, what's the importance of federated learning, and how you should do it using PySift. So I think we can wrap it up here because I'm getting late.
Yeah, sure. Thanks, Arnav. Thanks a lot for your time. Sorry
yeah.
for the delay.
So like I can like give you a few minutes, like if anyone has any questions.
I guess no one has any questions. It's completely new topic.
Okay.
So
Okay.
Arnav,
Also, can you just, Prabhu, can you let me know like where are you going to make the recording available?
in Zoom, I'll send you the recording.
No, I'm asking like, are you going like? Okay, fine. We can take this offline. Fine. Okay.
Yeah. Thank you, Arnav.
Okay.
Thanks for your time. Bye, Arnav. Thanks a lot.
Yeah, sure. Thanks, man.
Thanks, Arnav. Thanks a lot. Bye.